Hello everyone, welcome to our class. Today we will talk about caching algorithm. So we will talk about two different caching algorithm, LRU and LFU in today. So what's a caching algorithm? Why we need caching algorithm? Let's start. So we have, in these memory hierarchies, the existence, we have a different layer of the memory. And if we want to get the data from our memory, we load the data from the memory to the L2 cache, to the L1 cache, then use it's in your register to compute for data, right? So we cover different like a caching, like a placement like algorithm. So we have direct mapped cache, we have a two set, like n set associated cache. We have four associated cache. So that's a different way to do it. But okay, so assume right now we have two set associated caches here. And because it's two set, so each two like spot, like you try to combine two spot to a group. So even though in this case, we only have four space, 1, 2, 3, 4, we try to group each two here as a pair. Imagine that you have a TA. I pair the TA together. So you have a question. You just go to find like either one TA in this pair to help you. So same thing here. If we want to load the data, for example, I want to load the data here, which ID the block ID is one, block address is one. Then we load to this pair because this should be 0 and 1. We use mod to try to like separate like the job. Okay, so these data should be lost to the second group. Okay, and depends on like the empty. If this is empty, for example, if there's something already in here, and you of course you can load to here, right? You can load to here. But here's the thing: if I already have something inside here, and right now I want to load the data from here into it, and they are not different. So I need to replace one data inside this block, inside this set, right? So which block I want to kick out from the set? I want to kick out this one or this one. Okay, so this is something like a new questions we need to solve, the new problem we need to solve. Which which block I need to kick out? Okay, so that's the topic for today. So we will talk about two different caching algorithms, least frequently used algorithm or least recently used algorithm. Uh, so these two algorithms has two different ideas. So depends on your like architecture design, your cache design. You can choose either algorithm to deal with the conflict. If your set is full and you want to replace one data inside it, which data you want to kick out? So the first one is the least frequently used algorithm. For this one, we have a special like a counter. So this counter will count each block, how how often this block used. So how often this data be used. If I keep using it, for example, I have a for loop I equals 0, I less than 100, I just keep using it, then which means the I is so important. So I will keep try to like store. I try to keep the I on the cache. I just like keep using it. So in the other word, if this object, this block like hasn't been used like a lot, it's just like randomly be used once and never be used again. So in this case, the frequency will be really, really low. In this case, we can kick out the low frequency, frequently one, uh, and replace it by the new one. So this is the idea. We try to load this data. You can see that this is a block address of 2417, this kind of stuff. And we load the first one, 2, into our cache. So this is our memory. This is the memory address, and we load to a cache. So when we load the block 2 here, we change the count equal to 1. Okay, so and then we just like put 4 here, put 1 here, put 7 here. So we try to load the data into a cache, and we give a counter. And right now we load 2 again because 2 is already in the cache. So we will increase the count and increase the count for 1. And right now, because we have 3, so 3 is a new one. 3 is not here, right? The address 3. So we definitely need to pick 1 to kick out. Do we want to kick out 2? Definitely not, because we use 2 a lot. We don't want to kick out 1 here, 2. So we just pick 4 or 7. But actually, based on the order, we kick out 4. So you can kick out 7, you can kick out 4, depends on how you decide. But we usually just kick out the first one, 4, here, and put 3 into it. Okay, so when we do the A, we can kick out 3 and 7, but we usually just kick out the first one in the cache. So we kick out 3 and put A. And for the 4, again, we need to kick out it again. And 1 is here, A is not here, so we kick out A, and so on. So in the end, you will see there's a lot of hit and miss happen. Actually, we have a lot of miss because we just keep try to update this 1. We don't update 2 or 1 because we have a multiple 2 and 1. But at the end, we just keep swap the 3 and A here. So in this case, actually the cache miss rate is a bit high. But again, even the cache miss rate is high for this case, it's still a really good algorithm, implement in our cache. So we can still use this algorithm because if you have a much bigger data, actually in the future you will see a really long data. You will find that the cache miss rate will be really low after these algorithms. Okay. So the second algorithm we talk about least recently used. So the idea is totally different. In this case, we don't count. We assume the data you use recently, you will use it again and again and again. For example, we use for for loop I, and I equal to 0, I less than some number. So we will keep use I, right? So I will be used again and again and recently. So if we finish the for loop, even the I has a really high frequency. For example, I equals 0, I less than 1 million. That's a minimum count for this I, because we will try to not use it anymore and in the future. So the I eventually I will be disappear from your cache. But if we use LFU, the frequency, because we use million times of I, so the counter of I will be really high. So we probably just keep I always be in your cache. Okay, so this is another algorithm. We try to use the data. We try to keep the data we just used recently. Okay, so let's see how this is do. So first one, we have 2. So we put 2 here. And when we put 4 here, we will move the order. We will change the order of 2, right? Because the 2 right now is the old one. So if right now we want to replace 1, we will definitely replace 2 because 2 is the old one. And we load 1. Of course, it move 7, we move. So here you can see the 2 is the oldest one, and it should be the 1. If we have a conflict, this should be the 1 we want to remove. But here we load 2 again. So we move 2 back to the top. So we move 2 back to the top. So right now 2 is the newest to 1, 4 is the last one. Okay, and we get 1, so we move 1 to the top. Okay, 3 here, because 3 does not show here, so we need to kick out 1, and we choose the oldest 1, which is 4. So 4 change it to 3, and 3 is the nearest 1. And we change A, we change 7 because A is new 1, so we change 7 to A. So we have A 3 1 2. And for when we see a 4, we replace the 2. So again, 4 is the nearest is 1, and 1 is the old one, but we promote because this is the new this one, the recently one, so we move to the top. And we put A, move to the top, and A, move to the top. In this case, we can slightly increase the hit rate, so reduce the miss rate for this algorithm. Okay, so but again, LFU, LRU both are really good algorithms. How you design your hardware, you can choose either one to support. So this is for LFU and LRU, and of course there's other algorithm you can use to predict for the future. You can have some fancy algorithm, a different algorithm to deal with this. But these two is most common algorithm in the world, like LFU, LRU is really, really common, not only for cache, it can only support system stuff, not just for cache. Okay, so this is the caching algorithm. Okay, so I hope you understand what this algorithm means here. Actually, this is not so difficult to play with it. Just practice with some example, you will get the idea. The idea is that when we have a conflict to our the set, the data in the set, and the set is full, so we cannot put any new data into the set, what should we do? So we need to figure out which one in the set we want to kick out, we want to replace it. So that's a two algorithm. LFU, we just count how often you use the data, use it to decide which data should be kicked out. Another one, LRU, is we just choose the oldest one. If you don't use this data for a while, then maybe we should just kick out this old data. So there's two different algorithms, and depends on like the design purpose, you can choose either one, and both are really good algorithm. Okay, so I hope you enjoyed today's video, and I hope you understand how to use, how to play with these algorithms for your cachings. Okay, so see you next time. Caching algorithm is awesome.